What's the status on the main fractionator?
All parameters are green, Supervisor. Running smoothly.
Check the flow rate on the schematic.
It's stable, but the analog gauge is fluctuating.
Towering refinery columns and pipe networks stretch across the complex, while crude oil is actively circulated through interconnected systems.
That gauge is reading high. Let's reduce the cycle rate.
Acknowledged. Reducing rate now. Check the ultrasonic reading on valve 3.
Reading confirmed. No anomalies detected.
From the storage tanks, the crude is accelerated by powerful pumps, flowing rapidly into the initial processing units of the refinery core. Crude oil enters large desalting vessels, where water is injected to remove salt and impurities as internal mixers churn continuously.
Separated water and contaminants settle out, while purified crude oil flows upward toward the next stage.
Crude oil enters these towering heating furnaces, where temperatures rise rapidly to prepare it for separation.
The temperature on gauge 7 is still fluctuating.
Try increasing the flow rate by 5% and monitor the pressure.
Separated fuel fractions exit the distillation column through dedicated pipelines, each stream flowing toward further processing units.
We're seeing a slight increase on the overhead temperature.
Okay, modulate the reflux just slightly to compensate.
Heavier oil fractions are transferred into a vacuum distillation unit for deeper separation under reduced pressure. Dense residual oils are extracted from the vacuum column base and routed toward upgrading units. Heavy oil fractions enter catalytic cracking units, where large molecules will be broken down. The amber glow signifies the intense catalytic reaction. Here, heavy hydrocarbons are broken down into lighter.
The newly cracked fuel streams flow through insulated transfer lines toward the cooling and separation units.
Hot cracked fuels pass through large heat exchangers, where temperature rapidly drops for stabilization. Recovered fuel gases are routed through overhead pipelines for reuse as refinery energy sources. Pressurized hydrogen mixes with fuel inside sealed reactors to cleanse sulfur and contaminants.
Inside the chamber, controlled heat initiates the reaction as the raw fuel contacts the catalyst beads.
Purified fuel exits hydrotreating units and flows toward blending systems.
Refined fuel streams enter precision blending valves, where different components are proportioned for final specifications.
Real-time sensors analyze blended fuel quality as it flows past inspection ports.
Finished blends rest briefly in stabilization tanks to equalize temperature and composition.
In video title, internal agitators gently circulate fuel within holding tanks to maintain consistency. Displaced vapors are captured through recovery lines to reduce emissions during stabilization.
Here, the final polishing filters remove microscopic particulates from the blended fuels. The pressure gauges remain steady.
Clarity is optimal right here. Confirmed. Pressure holds steady.
Finished fuels route through main headers toward large-scale storage facilities.
Thermal systems regulate stored fuel temperature for long-term stability.
Safety systems continuously scan storage tanks for pressure and leak integrity. Secondary processing concludes as stabilized fuels stand ready for downstream handling.
Stabilized fuels move from storage through a dense pipeline routing network, directing products to assembly systems.
Fuels converge at a central manifold, distributing output to multiple downstream paths.
Flow meters synchronize output rates across parallel lines for balanced distribution. Automated samplers precisely extract micro quantities of fuel for verification. Verified fuel streams transfer onto final assembly lines for packaging preparation. Surge tanks buffer fuel flow to maintain constant downstream pressure. Precision regulators stabilize pressure before packaging stages.
The alignment is drifting slightly on the left guide. I see it. Making the adjustment now. It's holding steady.
Centralized control panels synchronize pumps, valves, and conveyors in real time. Fuels continue advancing smoothly toward quality inspection without interruption. Inspection data streams into automated verification systems, confirming compliance standards. Approved fuel streams pass through automated gates, signaling readiness for packaging. The flow is steady and precise. Certified fuel streams receive automated clearance to move forward in production.
Verified fuels transition seamlessly from inspection into the packaging area.
Calibrated flow meters precisely measure the exact volume as the fuel moves steadily through the transparent sections of the pipe. Fuel streams pass through thermal stability units, where heating coils and cooling jackets operate in sync.
Microsamples are continuously diverted for real-time monitoring without interrupting flow.
Automated systems finalize compliance confirmation as fuel passes the last verification stage. Approved fuel is routed through dedicated pipelines toward packaging with no interruption.
Containers pass through electronic leak detection sensors, ensuring full integrity.
Automated systems check for spills or overflows as containers move along the line.
Check the inbound shipment on rack 12.
Looks like a discrepancy of 5 units.
Easy. Bring it down just a few more inches. Watch the line.
Loaded containers are sealed and secured for global transport.
Lowering the stack, confirm clear path.
Path is clear, bring it down slow.
We need this aisle clear. Take the blue bins to receiving, stack them high.